Now what we'll do is we'll go to the workbook for the last few pages to go through an example. This example can be gone through with any of the supports and any of the load cases. So here we'll focus on support A3, which remember, we're looking at the Z direction incline support. And we'll focus on analysis set 1 and the wind 2 load case. So I'll draw the support and the pipe in the middle. And remember that we're saying there's a 1-inch gap when looking down this pipe to the left and the right at this support. And we'll say the Z direction is this way. Excuse my poor drawing, but hopefully it helps to understand. In the gravity case, the pipe moves very tiny bit in the negative Z direction to right around here, let's say, negative 0.063 inches. So this becomes the initial state for the wind case. The pipe now, due to wind, can move either another 0.937 inches in the negative Z direction or a positive 1.063 inches in the positive Z direction before closing a gap and hitting a support. The wind load causes the pipe to move a positive 1.063 inches. It closes the gap, it hits the support, and it produces a force. Notice that there's also some movement and some force produced in the X direction. This is due to the fact that we have a friction coefficient applied. So it's important to be aware of that. But really we're focusing on the Z direction here because that's where our support is and that's where our gaps are set. Let's go to the next analysis set. Again, still focusing on support A3, the Z direction incline support with the 1-inch gap. And again, I'll do my best to draw this example. Positive Z this way. So in this case, in this analysis set, we said that OP1 was the initial state for our wind 2 load. That means, in this case, that we're taking into account gravity, then thermal, and then the wind load. We didn't include pressure extension in this analysis, so we aren't including the movement from the pressure in this case. So if we start with our pipe in the very middle of our support, the gravity load is applied and the pipe in the Z direction moves in the negative 0.066 inches. So just a very tiny bit this way. This is now the initial state for our thermal load case. Our thermal load can either make the pipe move 0.934 inches in the negative Z direction before hitting the stop, or positive 1.066 inches in the Z direction before hitting the stop. The thermal load makes the pipe move more in the negative direction, negative 0.138 inches. So again, a little bit more, but still not hitting the stop. This is now the initial state for our wind load to be applied. So the wind load can either make the pipe move in the negative Z direction, 0.796 inches, or in the positive Z direction, 1.204 inches. We know from the last example that the wind load makes the pipe move in the positive Z direction. It's still the same load being applied. It's still going to make it move in the positive Z direction. It just has a different amount that it's allowed to move. In this case, it makes it move all the way again to the stop, 1.204 inches, and it lands there at the stop and produces a force. The force that it produces, notice that it's less than the force that was produced in the last case, 554 pounds versus 273 pounds, because the pipe was allowed to move a bit more this time, 1.204 inches compared to 1.063 inches before it hit the stop. So that little bit more of allowable movement allowed the force to dissipate a bit. So that's example 1, analysis set 1. Example 2, analysis set 2 with OP1 as the initial state. Let's then look at example 3, analysis set 3, where OP2 is the initial state for our occasional loads, our wind load. And again, if I draw the support, starting at the very center, 1-inch gap to the left and the right, negative and positive Z direction. Let's see what happens. The gravity load is applied and the pipe moves in the negative Z direction, 0.069 inches. So now when the thermal 2 load case is applied, the pipe can move to the left another 0.931 inches or to the right in the positive Z direction, 1.069 inches. The thermal load case in this case at 550 degrees, a lot hotter than it was before, actually makes the pipe move all the way to the left, the total of 0.931 inches, until it hits the stop and produces a force. This load case, this total load case, is GT2. So if we look back at autopipe at GT2, if I turn that load case on, for A3, we do see that there's a force produced in the negative Z direction because we totally have closed that gap of 1 inches with the gravity and temperature load in the negative Z direction. So going back to the topic of our wind, after gravity and temperature, the pipe actually closed this gap and produced a force in the negative Z direction. So with the wind load, it cannot move to the left or to the negative Z direction anymore. It's already stopped. It could produce more force, but it can't move anymore. But it can move to the right or in the positive Z direction, the total of 2 inches. The gap was 1 inch to the left and the 1 inch to the right. When it moves all the way to the left, we now have 2 inches to the right to move. Again, we know that this wind load wants to move the pipe in the positive Z direction to the right. We just don't know how much. Is it enough to actually close this gap all the way? And it just so happens that it moves the pipe all the way back this way, closes the gap 2 inches in the positive Z direction, and again produces a force in the positive Z direction. So in this critical load case, you see that if the wind isn't applied, you already have a force on this support in the negative Z direction just from gravity and thermal. If the wind is applied, you have a force on the opposite side of the support with gravity, temperature, and wind. And the support would have to be designed for both cases. Again, you see that because the pipe had more room to move in the positive Z direction due to the wind load, this load of 185 is less than the 273 that we saw in the last example and the 554 pounds in the first example with the gravity load case. So I hope this example helps to make sense about load sequencing and being sure to understand what loads are being applied in each analysis set and in what order. And that will really help you to understand your results better. It's very important to be aware that you should not look at loads for intermediate load cases such as thermal and wind. You want to look at your loads for your realistic real-world load combinations. Gravity will always be a realistic combination. And then here's your total combination, gravity, temperature, and wind. These are the combinations you want to look at and you want to review. So actually, I just made a mistake and actually said that the total load was 185 pounds. And I was wrong, actually. Remember, the pipe had 2 inches to move to the right. It moves all the way in the wind case and closes the gap. It applies 185 pounds to move that way, but first it has to overcome the negative 166 pounds of the thermal load, which leaves us with an actual total load on this support of 19 pounds. This tells me that if my gap was just a bit larger than the 1 inch in both directions, I probably wouldn't even close the gap. Let's say it was 1.5 inch in each direction. That would have given me more room to move to the right. I probably wouldn't have closed the gap. Notice how slowly, the more room we have to move in the positive Z direction due to the wind load, we're diminishing our force in the Z direction on this support. So again, looking at that total load case is important. That's going to be your realistic loads, the loads that you want to design your supports for. And while the intermediate load cases like thermal and wind are useful to review the displacement plot, they should never be reviewed for your forces and moments, your support loads, your anchor loads, etc. Always look at your total load combinations. This concludes the nonlinear analysis using load sequencing training class on the Autopipe Intermediate Learning Path. Thank you for joining.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.